Hello, student. This is Darasa Online. My name is Edgar Mshana from Kibaha Secondary School. In this part of presentation, we are going to share the revised question in the topic of probability. And specifically, we are going to revise subtopics in the following subtopics. Number 1, we have factorial notation. And number 2, we have permutations and the combinations. Now, let us start with the factorial notation. Consider the numbers, the product of numbers which descend like, that is 4 times 3 times 2 times 1. And again, suppose you have the longest product of these numbers. Like we have 100 times 99 times 98, then they proceed up to 3 times 2 times 1. Now, to write the longest product of numbers like this one, it is a tedious work. But by using the concept of factorial notation, we can simplify the work. For example, the first case, you just write this is 4 factorial. And for the second case, this can be written as 100 factorial. Therefore, the issue is so simple, and you can use it even when you have given the question of this nature. Now, my dear student, let us see the general formula for factorial notation. For positive n numbers, the factorial of n, this is the same as n minus 1, n minus 2, they proceed up to 1, as I said that the numbers descend. Now, let us see an example on how to use factorial notation. My dear student, for example, you have the question like 5 factorial. That is, evaluate 5 factorial. This one is so simple because we have the general formula for factorial notation. Then you can use that general formula as displayed in our PowerPoint, like we have 5 times 4 times 3 times 2 times 1. Something which is so simple. Or you can decide to use the scientific calculator. I think most of you have a scientific calculator. Now, let me show you how to end up to the correct answer. That is, our question is to evaluate 5 factorial. So this is 5 factorial. So 5 factorial, here we are going to end up with 120. My dear student, I think we are together, and you are trying to use your scientific calculator so that you can get the same answer as me. My dear student, let us see the second question. Consider the question like 45 factorial over 43 factorial. A little bit not the same compared to the first example, but again, it is so simple. By using our general formula, as you can see, this is the same as we start with part of the numerator. The numerator will 45 factorial. 45 factorial is the same as 45 times 44 times 43 factorial. Why are we ending in 43 factorial? That is because in our denominator, we have 43 factorial. So this one divide by 43 factorial. Now, our work is so simple because now we can simplify the case like 43 goes with the 43. Now, what remains in our solution is equal to 45 times 44. So, my dear student, by using your scientific calculator, you can compute the product we have here. That is 45 times 44. The answer will be 1,980. But again, you can go straight by using your scientific calculator has a function for factorial notation. By using your scientific calculator, you can use the symbol for factorial notation and get the same answer. Okay, again, my dear student, suppose we have another question like we have 2 factorial bracket 4 plus 3 factorial. Even this question is so simple because it's just a matter of operation. Where to start? We can have that just say solution. That is 2 factorial. We can start with the operation which is in the bracket. That is 4 plus 3. Remember, these numbers inside the bracket has no factorial notation. So just add it directly. Like 4 plus 3, here we are going to have, that is 7 factorial. Now, you can go straight by applying the general formula for factorial notation as already mentioned earlier. This is the same as saying that is 2 factorial, that is 2 times 1, because the number should descend. And again, for 7 factorial, this is the same as 7 times, we have 6 times, that is 5 times 4 times 3 times 2 times 1. Now, you can use your scientific calculator again to find the answer. My dear student, I think all of you have the scientific calculator. It is so simple to use. Now, you can plug in what we have. You can go direct to the question, or you can find the answer by using the last expression we have. That is, we have 2 factorial times, we have 7 factorial. That is 7 factorial. Now, the answer here will be equals to, it is 1, 0, 0. That is 10080. Let me write very clear. That is 180. Now let us proceed with another example. Suppose the operation change. Like this time we have 7 factorial minus 5 factorial over 6 factorial minus 4 factorial. Even if the operation change, you can look the question, because remember, we have the general formula for factorial notation, but again, you can use your scientific calculator and end up with the correct answer. Now, suppose we want to show the way of how to do such kind of a question. My dear student, it is very simple. For 7 factorial, this is the same as 7 times 6 times 5 factorial. Why 5 factorial? because the last number is 5 factorial. It will help us to simplify the expression. So here we just say minus 5 factorial over, for the denominator side, we have 6 factorial minus 4 factorial. So we start with the 6 factorial, which is 6 times 5 times 4 factorial. Why 4 factorial? Because the last number is 4 factorial. So here you minus 4 factorial. Now you can see for the numerator side, we have 5 factorial, and the last one is 5 factorial. It means you can write 5 factorial out of the bracket. My dear student, what will remain here? It will be 7 times 6 minus. Here 5 factorial is out of the bracket, so we are going to remain with 1. For the denominator side, what is common is 4 factorial. So you can write 4 factorial out of the bracket. 4 factorial out of the bracket. My dear student, what will remain here? You can see we are going to have 6 times 5 minus 1. Why 1? Because 4 is out of the bracket. Now, again, you can use factorial notation to simplify 5 factorial over 4 factorial, like that is 5 times 4 factorial. Now, why 4 factorial? Because remember, in our denominator side, we have 4 factorial. So now here we have 5 times 4 factorial, bracket, we have 7 times 6 minus 1, bracket, over. For the denominator side, we are going to remain with the 4 factorial, bracket 6 times 5 minus 1, bracket. Now you're in a position to simplify, because in the numerator side, we have 4 factorial, but again, in the denominator side, we have 4 factorial. So you can simplify very easily like this. So here we are going to remain with 5 times. Now remember, in the bracket we have 7 times 6. 7 times 6, this is 42 minus 1. Over, for the denominator, we have 6 times 5 minus 1. But 6 times 5, this is 30 minus 1. So, my dear student, we are going to have 5 times. Now, inside the bracket, we have 42 minus 1, which is going to be, that is 41, over. For the denominator side, we have 30 minus 1, which is equal to 29. Now, again, my dear student, you can use your scientific calculator to find the final answer. So just take your scientific calculator and plug in the data remain. That is 5 times 41 divided by 29. Now, the final answer is equal to 7.068965517. I think even you have the same answer as you have seen here. We have seen how to use the factorial notation, and you have seen the general formula of factorial notation. Now, let us see the application of factorial notation. And one of the areas where we apply the factorial notation is permutation. Permutation, of course, and the combination. But these two words, permutation and combination, confuse some of the students. Now, to clear the doubt, I will differentiate between permutation and the combination as follows. My dear student, by definition, permutation refers to arrangement of other things out of any things when order is important. That means when we are talking about permutation, the order is very important. And it is general formula. It is NPR is given by n factorial over n minus r factorial. Remember, we've already discussed about factorial notation. So when I write factorial, I think most of you are familiar with factorial. When we go for the second case, that is combination, by definition, the combination refers to the selection or choosing of items when the order is not important. So the issue to care here is that combination is selection or choosing of an item whereby order is not important. Now you can see the differences between permutation and the combination. In permutation, the order is very important, but for combination, the order is not important. Now, my dear student, consider three pieces of marble. Three pieces of marble, labeled A, B, and C. We're having three pieces of marble, which are labeled A, B, and C. For the case of permutation, if we want to choose only two pieces of marble out of three, we could say 3P of 2. Why? Because we are having three marbles and we want to choose only two. So by using our general formula, we could say this is the same as 3 factorial over 3 minus 2 factorial. What are we going to get here? This is equal to 3 factorial over 3 minus 2 remaining with 1 factorial. So 3p2 will be equals to, now remember this, the expansion for 3 factorial by recalling the general formula for factorial notation is the same as 3 times 2 times 1 over, now remember, 1 factorial is equal to 1. So here we just write it over 1. So 3p2 will be equals to 3 times 2 times 1, which is equal to 6. Now again, this is permutation. Now suppose the same case, 3 pieces of marble, we need to choose 2, where the order is not important. We could say this is 3c2. I think remember the formula. That is 3 factorial over 3 minus 2 factorial 2 factorial. That is for the case of combination. Now, what are we going to get here? Remember the concept of factorial notation. That is 3 times 2 times 1 over, now again, the number which are inside the bracket has no factorial notation. So just take 3 minus 2. You are going to remain with the 1 factorial times 2 factorial. Now, that is 6 over, remember I said 1 factorial is equal to 1. And the 2 factorial is the same as 2 times 1. So the last answer you can simplify here by saying by 2 is 1, by 2 is 3. We are going to end up with 3. Now, my dear student, you can see the differences between permutation, where we choose 2 items out of 3 with order important, and case 2, that is combination, We have 3 mabels, but we decided to choose only 2, but order is not important. We end up with 3. What does this mean? In arrangement, we can do as follows. Remember case 1, this is permutation. That is permutation. And case 2, this is combination. Let me show you. Then we will differentiate between permutation and the combination. We said in permutation, the order is very important. You arrange 3 pieces of mabel in order. But of course, remember, we choose only 2 mabels out of 3. So we could say you can choose A, B, that is 1. But again, the second case can be B, A, because the order is important. AB is not equal to BA. But again, you can say A, C, C, A, because AC is not equal to CA, because in permutation, the order is very important. And the last case, it can be A, C, that is B, C, and C, B, because BC is not equal to CB. Now, try to count these items we have. We have 1, 2, 3, 4, 5, and 6, which is the same as the answer we got here. But for the case of combination, remember, order is not important. For the case of combination, order is not important. So A, B is the same as B, A. You can group like this. That is AB is the same as BA. Why? Because the order is not important. And again, AC is the same as CA. Why? Because the order is not important in combination. And the last one is BC and CB. So now try to count what we have. We have 1, 2, 3. So we end up 3 items, which is the same as 3 we got by using the general formula. My dear student, remember what is important in combination and permutation. For combination, the order is very important. But for combination, the order is not important. That is what differentiates between permutation and the combinations. I think we are together up to this moment. Now, my dear student, let us see some questions. And I'm sure you are going to join with me and tell me that the question, is it fall in permutation perspectives or combination perspectives? The first question, my dear student. How many ways can you arrange 5 books on a shelf? How many ways can you arrange 5 books on a shelf? Now, by using the 2 definitions of permutation and combination, remember, in permutation, the order is very important. And for combination, the order is not important. Now, in this question, which perspective suits our question? Is it permutation or is it a combination? Try to think. My dear student, I'm sure that you will join with me that in this question falls in the first perspective, that is permutation. Because when you arrange books in a shelf, there is a certain order to follow. Therefore, for our case, how many ways can you arrange 5 books on a shelf, it will be the same as 5p of 5 because there should be any order. Now, by using our general formula for permutation, this is the same as 5 factorial over 5 minus 5 factorial. Remember, the general formula for permutation is equal to n factorial divided by n minus r factorial. That is our general formula. That is why we just plug in 5 factorial over 5 minus 5 factorial, which is the same as, remember the expansion for 5 factorial, our first definition of factorial notation. This is equal to 5 times 4 times 3 times 2 times 1 over, then we have 5 minus 5. This is equal to 0 factorial. Now, for the part of numerator, you can use your scientific calculator to get the answer. I'm sure most of you who are taking basic applied mathematics, you have the scientific calculator. That is now for the case of numerator, we have the answer that is 120. For the case of denominator, we have 0 factorial. In mathematics, 0 factorial is equal to 1. So even by using a calculator, you can prove that is 0 factorial is equal to 1. So here we have 120 divided by 1. Therefore, the final answer will be 120. My dear friend, this topic is very simple. If you practice, you will be perfect. Now, my dear student, let us continue with another example. Okay, that is question number 3. That is question number 3. We have question number 3. The question says, how many committees of 4 people can be selected from a group of 10 people? That is your question we have. Now again, remember we've defined permutation and combination. You know their definition and you know how they differ. Remember, I remind you, in permutation, the order is very important. But for combination, the order is not important. Now, look to our question. If the question order is important or not important, try to think where you are. Try to read the question again and see whether the question falls in permutation perspectives or combination perspectives. My dear student, selection of a committee, the order is not important. This question falls in combination. Therefore, we could say remember we have a total of 10 people, that is n is equal to 10, and we need only to choose 4. Therefore, R here is equal to 4. Now, by using our general formula, we say that is n CR is equal to n factorial over n minus r factorial, then r factorial. That is the general formula for combination. Now, let us substitute what we have. So we have 10C4 is equal to the value of n, that is equal to 10 factorial over, then again we have n minus r, that is 10 minus 4 factorial, then again times r factorial, which is equal to 4 factorial. For this case, you can use your scientific calculator to find the final answer, or you can proceed like this. Remember the expansion for 10 factorial by using the definition of factorial. That is, we have 10 factorial. That is 10 times 9 times, we have 8 times 7 times 6 factorial. Why 6 factorial? Because we have seen 10 minus 4, that is 6 factorial, times 4 factorial. In this case, you can simplify 6 factorial and 6 factorial. That is why I end up in 6 factorial. Otherwise, if in the denominator side there were no 6 factorial, I could proceed until 1. So you can simplify this way. 6 factorial and 6 factorial can disappear that way. So we are going to remain with numbers without factorial in the numerator side. That is 10 times 9 times 8 times 7 over, for the denominator side, we have 4 factorial, which is the same as 4 times 3 times 2 times 1. Now, my dear student, again, we are in the position to use your scientific calculator to get the final answer. Now, take your scientific calculator and proceed with me. My dear student, I hope that you are going to end up the same answer as what I got here. That is 210. So 210, that is your final answer. Oh, my dear student, now it is time to hear from you. We have seen the differences between permutation and combination. But again, the knowledge of factorial notation. Now, I'm in the position to hear from you. This part of presentation, we have revised the questions concerning to factorial notation, that is factorial notation, and the second subtopic was permutation, and the third one was combination. For the case of permutation and combination, we have seen the differences between them. For the case of permutation, just to remind you, is arrange items with the care of order. But again, for the case of combination, the order is not important. Now it is time to hear from you. There is a number displayed on the screen. Now I'm ready to receive message from you concerning the lesson and this part of presentation. Welcome, my dear students. And after a short break, I will be back so that I can read your messages and solve the question that we are going to send via the number which is displayed on the screen. Okay, my dear student, I'm back. Here I have received a lot of messages via my phone number which was displayed on the screen. And I'll read the message. The first message says, "Greetings, sir. I am Gerard Jonas from Kakonko, Kigoma. I am very excited with the program. If you have a question that says 3 bracket of n combination is 6 bracket is equal to n combination 5. How do you solve it?" Okay, my dear student, this is a very nice question. we are going to apply the concept that we have already discussed in our review questions. Maybe let me copy this question as follows. That is, if we have a question that says 3 bracket of n combination 6 is equal to n combination 5. How do you solve it? My dear student, this question is so simple. As we have already familiar with the concept we have discussed, that is the application of factorial notation, but again, combination perspectives. Let us do the question as follows. Remember the formula for combination. The formula for combination says if we have n combination R, that is, you choose n items, you choose R items out of n items without care of the order, this is equal to n factorial over, that is, n minus R factorial and R factorial. That is our general formula for combination. Now let us see how this formula is useful for such kind of a question from Kakonko, Kigoma. Now, in our left-hand side, we have 3, which is out of the bracket. Then we have n combination 6. That is the same as n factorial, remember our formula, over, that is, n minus 6 factorial 6 factorial. That is the left-hand side. For the case of our right-hand side, we have n combinatory 5. Again, we use our general formula, that is n factorial over, we have n minus 5 factorial 5 factorial. Now, let us proceed with our left-hand side. That is 3 out of the bracket. Remember, we have n factorial. So, n factorial, we can descend it until we reach n minus 6 factorial so that we can be in a position to simplify it. So that is n minus 1. We have n minus 2. Again, we have n minus 3, n minus 4, n minus 5, and n minus 6 factorial. Why n minus 6 factorial? Because in our denominator side, we have n minus 6 factorial. So we should end here so that we can simplify our expression. So this one over, in the denominator side, we have n minus 6 factorial, and again we have 6 factorial. Then we close the bracket. Now, for the case of our right-hand side, let us again apply our general formula for combination. Proceed with me, that is, now this time we have n factorial over n minus 5 factorial, then 5 factorial. So we can descend n factorial until we reach the position of n minus 5 factorial so that we can simplify. So this one is the same as n. Again, we have n minus 1. we have n minus 2, n minus 3, we have n minus 4, that is n minus 4, and the last one is n minus 5 factorial. Why n minus 5 factorial? Because in our denominator side, we have the value of n minus 5 factorial. So this one over, or the whole thing over, that is n minus 5 factorial, 5 factorial. Now, the issue now is so simple, because we can look at the like terms and try to simplify them. So for the case of our left-hand side, we have n minus 6 factorial. This one will vanish with n minus 6 factorial. And for the case of our right-hand side, n minus 5 factorial will vanish with n minus 5 factorial in the part of the numerator. My dear student, what will going to remain? The expression in our left-hand side will remain, will be 3 bracket of n, again, n minus 1, we have n minus 2, n minus 3, n minus 4, and n minus 5. This one over. So again, we can consider 6 factorial. 6 factorial, we can descend it until we reach 5 factorial. So that is 6 times 5 factorial, which is the same as n. We have n minus 1, n minus 2, n minus 3, n minus 4 over 5 factorial. My dear student who are watching this lesson, you can see here this is 5 factorial. We can simplify it with 5 factorial in our right-hand side. But again, you can see some items which are the same. There are some items which are in left-hand side look the same with the item which are in right-hand side. Like we have n, which is the same as n in the left-hand side. But again, we have n minus 1, n minus 1. These are the same items. Another one is n minus 2 and n minus 2. Another one we have n minus 4, n minus 4, n minus 3, n minus 3. My dear student, we are going to remain with a very short expression which is equal to, maybe let me, so the remaining short expression will be 3 bracket of, here we remain with only that is n minus 5 over 6, which is equal to 1 over 1. So we no longer have factorial notation. So here we can do what we call cross multiplication. That is 3 n minus 5, which is equal to 6 times 1, that is 6. Now you can open up the bracket so that you can get value of n. So opening the bracket, we have 3 times n, we have 3n minus, again, 3 times 5, this is equal to 15. So the result is equal to 6. Now this is 3n minus 15 plus 15, which is equal to 6 plus 15. So here we have 3n, which is equal to, now 6 plus 15, this is the same as 21. Now, to get the value of n, remember, you just divide by 3 from both sides. So here you are going to remain with n is equal to, that is 21 divided by 3. This is equal to 7. Now, my dear student, we have the value of n for such a kind of equation. I'm sure that there is no longer doubt for such kind of equation for my student who sent this message from Kakonko, Kigoma. Now, let me read another message. Let me read another message because here I'm having a lot of messages, and I'll try my level best to make sure that I read this message. The second message says, greetings, the lesson has been so on point. I have a question that says, how many 8-letter pattern can be formed from the word Morogoro? This is coming from Baraka Swai, Kimara, Dar es Salaam. Oh, thank you very much, Baraka Swai, from Kimara, Dar es Salaam. Your question is so simple. Maybe let me try to write this question. That is how many 8 letters? That is how many 8 letters pattern can be formed from the word Morogoro. Thank you very much, Baraka Swai. Now, this question, we can apply the concept of permutation perspectives because it needs the arrangement of the word Morogoro, and of course it is a special case for permutation. Here there are some letters which are alike, which look the same. For example, we have O in Mo, we have O in R, we have O in G, and O in R. These letters are the same. So first of all, we can count all letters in the given word. So if we count very careful, we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 80, that is n is equal to 80. The total number of letters is equal to 80. And the letters which repeat, or the letters which are alike, we can call them, the first one is R. So how many O's we are having here, my dear student? Because we have 1, 2, 3, 4. So we have 4 O's. So these are the letters which are alike. How are the letters which are alike? Now if you read very carefully, you can see there is R. These R's are alike. So again here we have Q. We can call Q, taking into account errors which are alike. So how many errors we are having here? We are having only 2 errors. Up to this moment, there is no more letters which are alike. Now we are in the position to do the question. Now, if we are looking for a number of permutation, that is number of permutation, this is equal to, that is n factorial over, now for the case of denominator side, we find the product of the letters which are alike. The first letter is r factorial, but the second one we have q factorial. Now which is equal to, now n factorial, that is 8 factorial over r factorial, we have 4 factorial, and of course you have 2 factorial. Now for this case, you can use the concept of factorial notation to get the final answer. So this one is equal to 8 times 7 times 6 times 5 times 4 factorial. Now why 4 factorial? Because in our denominator side we have 4 factorial. So this will be divided by, we have 4 factorial. Now remember, 2 factorial is the same as 2 times 1. Now in this case, 4 factorial will vanish. Then take your scientific calculator and try to find the answer for what is remaining here. I'm sure most of you know how to use a calculator. Now this one is, it's very simple. Now we have the answer, and I'm sure my answer will be the same as what you got. So number of permutation will be equals to 840. Number of permutations will be equals to 840. So my friend from Kimara, my student, that is how to do such kind of equation. Now once again, let me continue to read the other messages, because here I'm having a lot of messages. The second message, my dear student, the question says, hello, it is Mariam Adam from Kisasa, Dodoma, a very spot on the program. My question is, how many selections of 4 letters can be made from the 6 letters A, B, C, D, E, F repetition? Oh, that is a very nice question, my students. Maybe let me write this question so that you can be in a position to read it carefully. That is question number 3. How many selection? That is how many? How many selection of 4 letters? Of 4 letters can be made from the 6 letters, A, B, C, D, E, and F. repetition. Yes, that is our question. Now, if you read very carefully this question, the question falls in the two previous parts we've already discussed, that is permutation and combination. And if you refer the definitions for permutation and combination, permutation is about selecting items with order important, but for the case of combination, the order is not important. Now, in this case, if you are dealing with a selection of given letters, you can select them randomly without caring about the order. So obviously, this question falls on the combination perspectives. Now, remember the general formula for combination. So combination says if you have a total of n items and your interest is to choose only R items without care of the order, this is equal to n factorial over, we have n minus R factorial, R factorial. That is the general formula for combination. Now, how many letters are we having here? That is, we have to count them. Almost we have 6 letters. Therefore, the value of n will be equals to 60. We just count these letters, the given letters, that is A up to F. And of course, from a total of 6 letters, you need only to select 4. That is 4 out of 60. So, of course, here R will be equals to 4. Out of 6 letters, you need to select only 4 without the care of order. So that is 60 combination 4 is equal to, now just substitute in our general formula. That is equal to 6 factorial over, we have n minus R factorial, that is 6 minus 4 factorial times R factorial, that is 4 factorial. Now, this will be equals to 6 factorial over, now here we have 6 minus 4 factorial. So we are going to remain with the 2 factorial times, then we have 4 factorial. Now, for the case of numerator, you can descend 6 factorial until you find 4 factorial. So this one will be equals to 60 times 5 times 4 factorial. Why 4 factorial? Because in our denominator side, we have 4 factorial. So that is 2 factorial times 4 factorial. Now, my dear student, you are in the position to simplify the remaining. So by 4 is 1, by 4 is 1. Now, you can get the final answer by taking 6 times 5. Here we have 30. That is 30. Over, we have 2 factorial, that is 2 times 1. That is, by 2 we have 1, by 2 we have 15. Therefore, our final answer is equal to 15. Therefore, such kind of equation, the selection will be 15 alternatives. My dear student, here I'm having a lot of questions, and much are coming. And we cannot afford to answer all the questions. But it is my hope that up to this point, now you are very familiar with the subtopics that we've discussed, factorial notation, but again, permutations, combinations, and you can differentiate them. That is from permutation and the combination. It is my hope that Till next session, will you join with me so that we can discuss the next topic? I'm very happy to share with you such kind of revised question. Till next time, thank you.